Dear students, in today's session, we will see another example of an ER diagram for a real-life situation. This question is taken from 2015-16 notebook test paper. In this question, we are going to draw an ER diagram for a management system of a small university. Let me start reading the scenario. The system keeps track of each department's ID and name. ID identifies each department uniquely. Here we can identify the first entity, that is department. Its related attributes are ID and name. Let's draw this entity and the attributes. As we discussed in our previous video, an entity is represented by a rectangle and the attributes are represented by ovals and connected to the entity. So the department entity and the attributes will be represented like this. Here the department ID identifies each department uniquely. Therefore, the primary key will be department ID. Let's continue reading. An ID, name and address describe each student. ID is unique for each student. Here we can identify the second entity, that is student, and the attributes are student ID, name and address. And the primary key will be student ID since it uniquely identifies each student. And if you consider the relationship, it says each student must register only in one department. Each department must register by at least one student. At least in the sense one or more students. Therefore, there is one-to-many relationship exists here. And it will be represented like this. One department can be registered by many students, but one student can register for only one department. And if you consider the cardinality, department must register by at least one student. So maximum up to any number of students. That is 1 and n in the department side. And the student must register at only one department, that will be both maximum and minimum 1 in the student side. Once a student registers in the department, the registered date should be stored appropriately. Here the registered date is needed only when a student registers. That means the registered date attribute belongs to the relationship registered by. So it will be represented in this way. Let's continue reading. Each lecturer has an ID, name and phone number. The value of ID is unique for each lecturer. Here we can identify the next entity, that is lecturer, and the attributes are lecturer ID, name and phone number. So we can represent that in this way. A lecturer may have several phone numbers. That means it should be a multi-valued attribute that stores multiple phone numbers. Therefore, we can represent this lecturer phone number attribute using double-lined oval. Each lecturer must work only in one department, and each department must work by at least one lecturer. That means one lecturer can work only in one department, but one department can have one or more lecturers. Therefore, the relationship here is one to many. And it will be represented in this way. And the cardinalities will be 1 and n in the department side, where the department can have minimum 1 to maximum any number of lecturers, as well as both minimum and maximum 1 at the lecturer side. Each student must taught by at least one lecturer, and each lecturer may teach many students or may not teach a student. That means for a student, taught by a lecturer is must, but for a lecturer, teaching a student is optional. Therefore, we represent the optional relationship using a circle at the end of the optional entity. So this is the final ER diagram. Hope you understand. Thank you for watching.